Hello everyone, welcome to Memoneet. So I am Prajita, your chemistry SME, and I am back here with all of you with another amazing lecture. So I hope all of you are doing good and the preparation is going great as well. Right, okay. So today, as you can see, the topic for our video lecture is solutions revision. Okay, now this is for BPT-3. So let me give you a very brief idea about BPT-3. So students, most of you are part of the Bhramastra test series, right? And you people have appeared for the BPT-1 and 2. So now on 16th of June, we are going to have our BPT-3 where the chapters that we are asking you is the some basic concepts of chemistry and solutions which have already been asked in BPT 1 and 2. And yes, we have given you video lectures for both these chapters where I have discussed the concepts. Okay, all the concepts related to these chapters. So those students who are new here, they are watching this for the first time. Please go through those video lectures to understand all the concepts of these chapters. And here we are doing the revision because BPT-3 is a cumulative test and we are doing revision in this case. All right. So students, if you don't know, so on this on the YouTube our channel, you have this playlist Shasar's batch for chemistry. So there you will find all the chemistry lectures starting from BPT 1. Okay, and previously I have made 2 video lectures for some basic concepts of chemistry numerical portion. Okay, so if you have not watched it yet, please go and watch that as well because both these chapters are going to come in the exam, and as I have earlier told you that both these chapters have more weightage of the numerical part. Okay, although yes, some conceptual questions are there, but mostly we have analyzed that the numericals are coming. All right. So basically whatever we are teaching you in these batches, and it's not anything random, okay class, we have analyzed the PYQs and we have found out that yeah, for these 2 chapters mainly you will be focusing on the numerical portion. Okay, like more weightage is being given to the numerical part because in solutions you have colligative properties, you have Raoult's law, you have Van 't Hoff factor. So that all is being covered in the numerical portion, and similarly for some basic concepts of chemistry also. So whatever we are telling you here is not random, it is analyzed. Okay, and so you can trust us and you can see how the questions are being solved. Okay, so today we are going to revise the chapter solutions. See, the concepts are being discussed in detail in the previous video lectures. So today I'll be focusing on a quick revision and then we will be discussing the questions. Okay, like again the numericals. At least I'll try to have one numerical problem from each of the topics so that you can understand how to solve those questions. Okay, and you can do well. And one more thing I want to tell you class, I am a little bit disappointed because I'm not getting any comments from you people. See, like you have to comment that are you liking what we are teaching you, right? Then only we can get to know now that you are understanding the things and what changes have to be made. So I told you, if you are having any doubts or problems, if you have not understood anything, please go through the comment section and comment there. Okay, whatever is the problem you are facing, if you like anything also, then also you can tell me that. Okay, so how will I get to know? I will get to know when only you are commenting. Okay, so I want to have your comments on this video. All right, so if you are having any doubts also, then also you can post your comments, so we will see it and we will try to cater to it. All right, so we are here to help you all, but you need to tell us that where are, like, what are the problems you are facing, is there any issue? Okay, and yes, for the issues also, we have our Telegram channel, the link to which is in the description. Please go and join that if anybody has not joined it yet, where we are giving you daily targets and quizzes for your preparation. Okay, everyone. So let us start with the revision. Okay. So in solution, students, the very first thing that we have studied is what is the solution. So we know that it's actually a homogeneous mixture of 2 or more substances. Okay, and we are basically focusing on binary solutions in this chapter. Binary solution means in which we have 2 components, right? So the two components that we have are solute and solvent. So usually we say ki the one that is present in large quantity is the solvent and the ones in a small quantity are the solute. Okay. So then if we talk about the types of solutions, we have different types of solution based on the physical state of the solute and the solvent. Like here we can see gas in gas, which is air. Then gas and liquid, it's aerated water in which carbon dioxide is being dissolved in water. Similarly, we have different types of solutions, right? And we have dealt with different types of solutions in this chapter. If I talk about your liquid solutions, okay, liquid solutions may we have studied a very important law, that was the Raoult's law. So this Raoult's law is forming the basis of many things in this case. So it says that whenever we are having any solution in which there are two or more than two volatile components, all right. So in that case, the partial vapor pressure of any component in the solution is directly proportional to the mole fraction. So let's say if I am having two components, that is A and B. So these are the two components of your solution. So the partial vapor pressure of A will be directly proportional to the mole fraction of A. Similarly, the vapor pressure of B will be proportional to mole fraction of B. Now if I remove this proportionality sign, I get PA is equal to P naught A XA, and similarly PB will be equal to P naught B X B, right, where this P naught is the vapor pressure of A in pure state and Pa is its vapor pressure in the solution. Of course it will change when you are mixing two volatile components, right? Similarly, P naught B would be the vapor pressure of the component B in the pure state. So this is what Raoult's law states, like it tells us about the vapor pressure of each component with the relation with the mole fraction. Okay. So students, the limitations of Raoult's law are like it's applicable to only very dilute solutions, and yes, I told you where there are only like non-volatile solute. Okay, means the two components are the volatile, right? So if there are non-volatile solutes, then it's applicable here. And here we are not talking about association or dissociation of solute, all right, that we have discussed in the Van 't Hoff factor. Then we have two types of solutions, ideal and non-ideal solutions. So students, ideal solutions are the ones which obey Raoult's law at all composition of solute in solvent and at all temperature. Means entire range of concentration pay. If the solution is obeying Raoult's law, then it is known as the ideal solution. So let's say if you have two liquids A and B, they will form ideal solutions. So now there will be some interactions AA and BB. So when these A and BB interactions are same as that of AB interactions, AB molecular interactions, then you get the ideal solutions. Okay, this is very important. Please keep it noted. The ideal solution में the AA-BB interactions are similar to the AB interactions. Okay. And जब ideal solution बनता है, these 2 points you have to keep in mind. They can be asked in your exam also. The delta H mixing would be 0, means when we are mixing those two components, no heat is absorbed or evolved, and delta V is also 0. See, delta H is 0 and delta V means change in enthalpy and change in volume is 0. Means no expansion on contraction of on mixing. मतलब जो volume पहले थी mixing से पहले, the volume will remain same. Okay, so that is what we call as the ideal solution. Okay, now non-ideal solution, students, again, which do not obey Raoult's law at all concentrations and temperature, right? So matlab they will show deviation from ideal behavior and they're not obeying Raoult's law over entire range of composition. So if they are not obeying the Raoult's law, so delta H mixing is not equal to 0. Okay, and delta V mixing is also not equal to 0. Okay, means there would be either heat absorbed or evolved, and the volume will also change. All right, it will not remain same. Now there is positive deviation and negative deviation from the Raoult's law. Positive deviation from Raoult's law means, here you can see, when the vapor pressure of the solution is more than what is expected from Raoult's law. मतलब जितना रॉल्स लॉ ने बताया उससे ज्यादा अगर वेपर प्रेशर होगा उस सॉल्यूशन का, then we are saying that it is positive, it is showing positive deviation from the Raoult's law, right? So what is happening in this case, students? Basically, if we are talking about interactions, so non-ideal solutions में the AA and BB interactions are not similar to the AB interactions. So यहाँ पर क्या होगा, the AA and BB interactions would be stronger than the AB interactions. So of course these are stronger, but when जब हम उन दोनों solutions को mix कर रहे हैं, so the interactions are not stronger, not that much stronger. So it means the vapors can escape easily, right? So अगर वो easily escape कर पाएंगे, so obviously the vapor pressure would be more ना. So that's why it's showing positive deviation. So ये आपको याद रखना है कि positive deviation में जो AB interactions होंगी, they will be weaker than the AA and BB interactions. Okay. फॉर एग्जाम्पल साइक्लोहेक्सेन एंड इथेनॉल के केस में, इथेनॉल के केस में देयर इज हाइड्रोजन बॉन्डिंग यहाँ पर, राइट? बट ऐसा नहीं होगा जब हम साइक्लोहेक्सेन और इथेनॉल को मिक्स करेंगे, सो ऑब्वियसली द इंटरेक्शंस विल गेट वीकर. सो इसी वजह से इट विल शो पॉजिटिव डेविएशन फ्रॉम द रॉल्स लॉ. हियर यू कैन सी द ग्राफ. ओके. Now students, if I talk about negative deviation from the Raoult's law, so negative deviation में क्या होगा, the vapor pressure would be less. Okay, means less vapor pressure than what is expected by the Raoult's law. अब यहाँ पर vapor pressure कब होगा, अगर AA interactions और BB interactions जो हैं weak होंगी than AB interactions. Means when you are mixing the two components, okay, सो जो उनके बीच में इंट्रैक्शन होंगी वो इतनी स्ट्रांग हो जाएंगी दैट इट विल नॉट अलाउ द वेपर्स टू एस्केप इजीली. ओके, वेपर्स कैन नॉट एस्केप इजीली इन दैट केस, एंड दैट इज व्हाई द वेपर प्रेशर, द ऑब्जर्व वेपर प्रेशर वुड बी less than what is expected. So in this case you have to remember the AB interactions are stronger than the AA and BB interactions. Okay, so the vapor pressure would be lesser. So that's what is shown in the case of negative deviation. All right. So students, then the next topic was your colligative properties, which we have discussed, that these are the ones that only depends on the number of solute particles. सिर्फ number of solute particles पे depend करेंगी, not on their nature, not on anything else. So that's denoted as, or that's known as, colligative properties, and we have discussed 4 colligative properties, that is lowering of vapor pressure, elevation in boiling point, osmotic pressure, and depression in freezing point. So lowering of vapor pressure, you know that we have हमने ये सब जो results हैं ये already derive करे हैं. If you want to see how they are derived, you can go to previous lecture of solution part 2. Okay, it was there in part 2. So there, part 2 and 3, there you can watch it. Okay. So whenever you know कि we are having a solution जिसमें we add a non-volatile solute, so if we are adding a non-volatile solute to the solvent, so in that case the vapor pressure gets lowered. Okay, and vapor pressure, so relative lowering of vapor pressure, so let's say if this is the vapor pressure of the pure component, okay, pure solvent, so उसमें से क्या होगा, the relative lowering, and P1 is the vapor pressure of the solution. Of course P1 would be less than P1 naught, so divided by P1 naught, because we are discussing relative lowering of vapor pressure, so that depends on W2 M1 M2 into W1. Okay, so where W2 and M2 is like the weight of solute and mass of molecular mass of solute, similarly W1 and M1 are the weight and the molar mass of the solvent. Okay. Now students, so here how we have derived this, it is basically the mole fraction. Okay, so relative lowering of vapor pressure is actually equal to the mole fraction of the solute. All right. Now students, we have discussed that addition of a non-volatile solutes lower the vapor pressure. Okay, so the vapor pressure of the solution will always be lower than that of pure solvent. So it must be heated to a higher temperature to make the vapor pressure equal to atmospheric pressure. So because we know कि boiling point is that temperature जहाँ पर vapor pressure becomes equal to the atmospheric pressure. So अगर वेपर प्रेशर लो हो गया है तो उसको एटमॉस्फेरिक प्रेशर के इक्वल करने के लिए वी नीड टू हीट इट मोर, सो दैट इज गोइंग टू इंक्रीज द बॉइलिंग पॉइंट, जिसको हम बोलते हैं एलिवेशन इन बॉइलिंग पॉइंट व्हेनेवर अ नॉन वोलेटाइल सॉल्यूट इज एडेड. ओके, so students, in that case we know the elevation in boiling point hai, we have seen ki it is directly proportional to the molality, all right, where delta TB is equal to kbm. Now this kb is the molar elevation constant and this is the relation to find out the value of m2. यहाँ से हम m2 की वैल्यू निकाल सकते हैं which is the molar mass of the solute. Okay, so delta TB is equal to kb into 1000 into w2. W2 is the mass of the solute, okay, like weight of solute present in your solution, and divided by m2 into w1, okay, mass of the solvent. Same goes with depression and freezing point. So depression and freezing point के case में भी जो delta TF है, so that will be proportional to the molality. So delta TF is equal to KF into M. So now this KF is going to be your molar depression constant or depression like freezing point depression constant. And the same relation goes here. So students, ये relations use करके we can find out easily the value of M2. Means M2 means the molar mass of your solute. Okay, so then the next one is your osmosis. So you know the osmosis is actually the passage of pure solvent. So pure solvent का जो movement होता है that is from a lower concentration to higher concentration through semi-permeable membrane. Okay, मतलब solvent की तरफ से it goes to the solution site. Okay, कि सॉल्वेंट की तरफ क्या होगा, आपकी लोअर कंसंट्रेशन रहेगी सॉल्यूशन की एंड हायर कंसंट्रेशन ऑफ सॉल्यूशन की तरफ वो मूव करता है. बट if we want to stop that movement, so excess pressure must be applied to the solution to prevent the flow of solvent. So वो जो excess pressure हम लगाते हैं just to stop the flow of solvent from solvent to the solution is called osmotic pressure, जिसको हम pi से denote करते हैं and it is like related to your concentration. So okay, सो यहाँ पर ये जो है कंसंट्रेशन के डायरेक्टली प्रोपोर्शनल रहता है. सो इफ वी सॉल्व दिस, सो इट बिकम्स पाई वी इज इक्वल टू एन आर टी. सो यहाँ पर जो v है आपकी वो वॉल्यूम ऑफ द सॉल्यूशन रहेगी, n इज द नंबर ऑफ मोल्स ऑफ सॉल्यूट, r इज द गैस कांस्टेंट एंड t इज एब्सोल्यूट टेम्परेचर. क्योंकि यहाँ पर हम मोलालिटी की बात नहीं करेंगे, वी विल बी टॉकिंग अबाउट द मोलारिटी. बट स्टूडेंट्स, दीज थिंग्स दैट वी हैव डिस्कस्ड एक्चुअली, सो ये ऑस्मोटिक प्रेशर और ये जो हमने कॉलिगेटिव प्रॉपर्टीज पढ़ी, these relations will be helpful whenever there is no association or dissociation. but जब आपका कोई solute like KCl है वो जाके आपका water में dissociate हो जाएगा, right? So in this case the number of particles of solute will increase, right? यहाँ पर dissociation हो रही है, so the number of particles is going to increase, right? सो वो इंक्रीज हो जाएगा तो उससे कॉलिगेटिव प्रॉपर्टी जो है वो यहाँ आपकी डिक्रीज हो जाएगी, राइट? लाइक जो मोलर मास है वो आपका डिक्रीज हो जाएगा क्योंकि कॉलिगेटिव प्रॉपर्टी बढ़ेगी तो मोलर मास डिक्रीज हो जाएगा. सेम गोज विद एसोसिएशन, राइट? लाइक जैसे आपका एसिटिक एसिड है, इट एग्जिस्ट एज अ डायमर. सो इन दिस केस एसोसिएशन इज हैपनिंग. सो जब भी डिसोसिएशन और एसोसिएशन होती है, सो वी हैव डिफरेंट मॉलिक्यूलर मासेस जो हमारे पास आते हैं एंड कॉलिगेटिव प्रॉपर्टीज भी अलग होती है. सो वैन टॉफ एक्चुअली गेव अस दिस वैन टॉफ फैक्टर आई फॉर सच abnormal केसेस जहाँ पर एसोसिएशन और डिसोसिएशन हो. सो आई की वैल्यू जो रहेगी दैट इज ऑब्जर्व कॉलिगेटिव प्रॉपर्टी, मतलब जो एक्चुअल है, डिवाइडेड बाय the theoretical colligative property जो हम expect कर रहे थे, right? Similarly, number of molecules actually present divided by number of molecules expected to be present. Like for अगर मैं KCl की बात करूँ, here we have actually two molecules, like double हो रहा है ना, like dissociation is happening. So I की value यहाँ हो जाएगी 2, and for association two molecules of acetic acid combine कर रहे हैं, they are forming a dimer. So यहाँ पर I की value क्या हो जाएगी 1/2, which is 0.5, क्योंकि एक्चुअल नंबर जो यहाँ पर वो क्या होगा, हाफ. Alright, so students, these all topics we have covered for the solutions. Now we will be seeing some PYQs and some important questions from this chapter. So you can get an idea as to how to solve the numericals. Okay. So students, let us start with the first question. So here I have taken this first question from your BPT-2. It was asked in your BPT-2. So it's actually related to the Rawls law. Okay, like I told you, we'll be doing at least one question for each of the topic. So Rawls law and Dalton's law of partial pressure combined. This question is from there. It says the vapor pressure of pure liquids A and B are 100 and 200 millimeter of mercury, respectively at 300 Kelvin. If the total vapor pressure is 175 mm of Hg, then the mole fraction of component A in liquid and vapor phase are. So basically what is given to us, we will write. So it's given the pure vapor pressure of pure liquids, means pure solvents ka vapor pressure is given. For A it's 100 mm of mercury, and P naught B is given 200 mm of mercury. Temperature is 300 Kelvin, of course. Total vapor pressure is given, class PT is 175 mm of mercury. We need to find the mole fraction of A in the liquid phase and in the vapor phase. So first of all, if I talk about the liquid phase, so you know, according to Rawls law, PA is equal to P naught A XA, where XA is the mole fraction of A in the liquid phase. Similarly, PB will be P naught B XB, right? This is according to the Rawls law. Now, if I apply the Dalton's law of partial pressure, okay, so what will be P total? P total would be PA plus PB. Alright, so that is your Dalton's law. So I will write P naught A XA. P total is already given 175 plus P naught B XB. Now I have to find the mole fraction of A in the liquid phase. So it means you know that the sum of mole fraction is always equal to 1. So instead of XB, class, can I write 1 minus XA? Yes, I can write it. So 175, it's P naught A XA plus P naught B 1 minus XA, I can write. So that now the whole equation is in XA and we can find out the value of XA, right? So chalo, let's put the value of P naught A and P naught B, which is 100 and 200. So 175 equals 100 into XA plus 200 into 1 minus XA. Alright, so we will be solving it. I'll tell you how to solve. So it's 200 minus this. So this is what you are getting, students. So from here you will get 200 minus 100 XA. So 100 times XA would be 200 minus 175. See, I am giving you each and every step so that there is no confusion in the calculation also. So from here the value of XA will be 100 or 25 upon 100, which is 0.25. So this XA that you are getting is the mole fraction of A in the liquid phase. Okay. So if you have got the value of XA from here, you can find the value of PA. Okay. So PA is PA naught into XA, which is 0.25. So here you will get 25 mm of mercury, right? Now that's the PA. Now why I have got the value of PA? Because I need to find the mole fraction in vapor phase. So in vapor phase, the value of XA is the pressure of component A. Alright, that's the mole fraction only. Now it's directly proportional to the partial pressure. So in this case of vapor phase, it will be PA upon P total, which is PA plus PB. Now PA, just now we have calculated, which is P naught A into. So here I will write Y, because here we are talking about in vapor phase now. So it would be YA. Alright. So it will be P naught A XA upon P total is already given to us 175. This I have already calculated, 100 into 0.5 upon 175. So from here it will be 25 upon 175, which is coming out to be 0.14. So in liquid phase it's 0.25 and in vapor phase is 0.14. So let's see the answer. Its answer is going to be option number 2. So class, this was a very important question, and like that was based on the Rawls law. So I hope everybody has understood how to solve it, right? So that was based on the Rawls law. Now we will be doing the next question. So now let us discuss the next question, students. So here the question is KH values for some gases at the same temperature are given here. Okay, and we need to find the correct order of solubility. So you see this question was asked in Neet 2022 Odyssey examination. It's actually a PYQ. So here we are talking about Henry's constant. So we will be talking about Henry's law first. So you know Henry's law tells us about the solubility of gases in liquid, right? So it says that the solubility of gases in liquids is directly proportional to the partial pressure of the gas, which is in equilibrium with the liquid, right? So if I talk about the expression of this law, so see, solubility of gases हम denote करते हैं with the mole fraction. So P is equal to KHX, right? So means P is directly proportional to the mole fraction. So in this case हम कहते हैं कि P is equal to KHX, where KH is the Henry's constant. So अगर मैं इसकी बात करूँ, it will go in the denominator and X is the solubility if I denote the mole fraction by the solubility. So in this case, students, what will happen कि higher the value of KH, okay, जितनी ज़्यादा KH की value होगी उतनी कम solubility होगी, because higher value of KH denotes that more partial pressure would be required to dissolve the gas. It means solubility would be less. Alright, so यहाँ पर आप देख सकते हो that argon is having the highest value of KH, so उसकी जो solubility है वो सबसे कम होगी, right? Then for CO2 it's there. Alright, after that it is methane, and then it's HCHO, formaldehyde. So that is going to be the correct order of solubility. So you have to remember that higher the value of KH, lower will be the value of solubility. Alright, students. So in this case, the answer is going to be option number B. Okay, so that was your PYQ, and yes, like I have told you earlier also, if you want to have a detailed explanation of all these PYQs and all the analysis, everything, so you must have our NTA PYQ book, right? So students, let's move on to the next question. So here it's a numerical problem related to the colligative property. It says when 5 gram of non-volatile non-electrolyte solute is dissolved in 100 grams of certain solvent, the freezing point decreases by 0.25 Kelvin. The molar mass of the solute is, right? So in this case, students, we need to find out the molar mass of solute. I told you now we can find out the molar mass of solute using colligative property. So we are going to do that here. So in this case, students, what is given to us? Weight of the solute is given, which is 5 grams. Weight of the solvent is given 100 grams. All right. So the depression and freezing point is given. Delta TF is 0.25. And KF value is also given. Firstly, we'll write whatever is given to us, 1.2 kg per mole. So this is also a previous year question. It has recently been asked in your NEET 2024 examination. So students, what we are going to do here is you can directly use the formula that I gave you, that is KF. So here we will write, please note, delta TF is equal to KF into W2 into 1000 divided by M2 into W1. So here we have to find M2. Rest everything is given to us. Directly we can use this formula and we can solve the question. Or else if you are not able to understand, or if you are not able to even remember the question, so what you are going to do in that case? So in that case, students, you know that delta TF is equal, directly proportional to molality. So delta TF is equal to KF into M. Now what is molality? So in that case, molality is equal to number of moles of solute which is present in given mass of solvent, or you can write mass of solvent in kg. Okay, so you can write mass of solvent in kilograms in this case. Alright, so students, number of moles of solute means given mass of solute upon molar mass and mass of solvent into kg. So यहाँ पर we can write W2 is 50, right? So not 50, it's 5 grams. Okay. So W2 is 5 divided by molar mass, let's take it M, and mass of solvent is 100. So 100 upon 1000. So that will be 0.1. So 5 upon M divided by 0.1 it is. So that will give you the molality. Alright. So it means it will be 50 upon M. So now we have got the value of molality which is 50 upon M. Now you can put this value here. Delta TF is 0.25. KF is 1.2 into 50 upon M. So from here M will be 1.2 into 50 upon 0.25. So now you will be solving it and you will get the value of molar mass, that is M. So after solving, it will come out to be 240 gram per mole. So that is going to be the answer. See, you can solve in this way also. If you remember the formula, directly put the values here. It's very easy to solve. Else you can first find out the molality like I have done in this case. And then you can put the value in this formula, that is delta TF is equal to KF into M. Alright students. So that is the case. So students, let us move ahead with the next question. So it's a different kind of question. It says which of the following aqueous solution exhibit highest boiling point. Now how you are going to solve this kind of question? So here molarity is given, right? Different types of solutions are given to you. Alright. So in that case, what we have to do is, you know that the elevation in boiling point is given like this, Kb into M. It depends on the molality of the solution. So here molarity is given and we are like, that is not going to make any change because it's a colligative property. So elevation in boiling point, it's a colligative property and that depends on the number of solute particles, right? So it depends upon the number of solute particles. So what we will be doing here is we will be finding out how many particles we are getting. So in this case, we have to use the Van 't Hoff factor also. I Kb M. Kb value is fine, right? It's constant, so we will do I into M. So here concentration is given. What we will do, we will multiply it with the Van 't Hoff factor. Now what is the Van 't Hoff factor in this case? We will see whether dissociation or association takes place. Alright, then we will find out the Van 't Hoff factor, because the one having the highest value will be of the number of solute particles will be giving you the molarity, like the highest boiling point. Okay, so in this case, so students, the first option is Na2SO4. So it will ionize to give you 2 Na plus ions and sulfate ions. So here in this case, the value of I will be 3. So I into M, like its molarity in this case. So it is 0.01 into 3. So it will come out to be 0.03. Now glucose and urea, they are non-electrolytes. Okay, means they will not ionize. So for glucose and urea, the value will remain same, that is 0.015 and 0.015. And for now NaCl will ionize as Na positive and Cl negative. So the value of I is 2. So I into M will be 2 into 0.001. So it will be 0.002. Now you can see the highest value out of this. So it's 0.03, this one and this one. So the highest value is coming out for the Na2SO4. So it is having the highest value of I into M. So it will be giving you the highest boiling point. So the answer is going to be option number 1. Okay. So students, this is how different types of questions we have discussed here from your BPT and from your PYQ as well. Alright, so practice such type of questions like the ones that were asked in the Bhramastra part test 2 and the BPT as well. Alright, and we will be like discussing some more questions and some more videos. Alright, so I hope this chapter is clear to you. The chapter that is solutions is clear to you. So practice some more questions, and in case you are having any doubts, please feel free to ask us through the comment section, or you can join the Telegram channel to interact with us. Okay, so thank you so much everyone. Take care. Bye bye.